they're not just super zealous about one database. They're thinking about like, how do we do distributed systems properly? Kubernetes being one of them. When I talk about composability, I think of the three parts of any distributed application, which is network, compute, and storage, which is ironically exactly what every cloud will sell you. That's really only what they want to sell you is network, compute, and storage. Everything else is to get you to use more network, compute, and storage. And that's what the breakdowns are. And, it's interesting because that's what Jeffrey and I were talking about last week is, there's every part, if you focus on every part and think about it in composable terms, like how are we going to make these work together? You can think of things instead of just one tarball to deploy. Like Cassandra is not just an executable. Thinking about it in terms of like, here's different parts that need to be put together. We've started going down this route on the project. And I think this is going to be a progression that we do over time. The Dynamo model is actually the one thing that makes the most sense because it is built kind of cloud. The Dynamo model, of course, and I keep throwing out the Dynamo thing, but Dynamo DB paper was written, the Dynamo paper was written by a group of engineers at Amazon in 2008. A lot of people think that's where DynamoDB came from. Nope, just name collision. But the Dynamo paper was around this idea of how do we distribute a database that is consistent and can be replicated and resilient. And it had to do with each node is shared nothing. And how do you manage that through the different bits of computer science? And if you look at that paper, it's an artful paper. There's 24 papers cited inside of that go into things like how to manage quorum data, how to replicate, how to manage consistency in those kind of situations, how to manage failure. And what we have is this availability. There's this CAP theorem, consistency, availability, and partition. Most databases up to that point were CP, consistency, and CP databases where, it's all about the consistency. And if you can't manage the consistency, then you don't do it. Sorry, shut down. You just don't let any more things happen. The Dynamo model changed everything to AP. It was on availability and partition tolerance. So you can have like two data centers that don't see each other and still be able to do live reads and writes, and that they'll rectify the data once they're connected together. So there were several databases that went that route: React, Cassandra, Voldemort, which is a really cool name. There's another one called Dynamite, which is hilarious. But there was a lot of databases that went that route. Cassandra is the one that's really kind of has survived and moved forward. But that model is valid in a Kubernetes world, because look at like when you do a deployment and you create all the parts, you're creating the ingress, the networking component, you're creating the nodes, which is the compute component, and then you're creating the storage, which is, that's the storage component, obviously. So I think this is where we are, is like, okay, this is the next level. And that's where when we bring in the people who can focus on those really interesting things, like what Jeffrey was talking about with storage, it's like, PVCs are a hot mess. I think we could do better. I tend to agree.